All right, earthquakes again. A little bit about predicting earthquakes this time. Predicting earthquakes, let me tell you right now, we don't predict earthquakes. We guess. Charles Richter scale. Dr. Charles Richter said, only charlatans, liars, and fools predict earthquakes. He's right. Only people who lie tell you, I know exactly when this earthquake is going to happen. No, you do not know when an earthquake is going to happen. But you can notice trends. For example, if I say, what state is there going to be an earthquake in today? Guaranteed 100% chance. Every one of you is going to say Oklahoma, right? I'm in California. But I would say Oklahoma. And I would say Alaska. Guaranteed, every day. Are they big? No. Are they dangerous? No. Are they going to hurt anybody? Probably not. But if I say, when is the next 7.0 dangerous earthquake gonna be, nobody can tell you. Every day Oklahoma has earthquakes. Every day Alaska has earthquakes. Every day California has earthquakes. But who's gonna predict that one earthquake, that big earthquake? Nobody's gonna predict that big earthquake. That's just not how it works. So throughout the world, every year, there are 900,000 small earthquakes. We don't feel them. If we do feel them, they're the rattling of windows. That's about it. Not very big. About 30,000 earthquakes. Well, actually, the 900,000 earthquakes are so small and nobody notices. About 30,000 earthquakes every year that you'll notice the shelves rattle, the windows would rattle, like a big truck driving by. About 30,000 a year worldwide. 500 a year that can actually cause some minor structural damage. About 500 worldwide, about 500 a year that can cause structural damage. California has quite a few of those. Oklahoma occasionally has one of those. Alaska, in the middle of nowhere where nobody lives, will have some of those. Japan has a lot of those, a lot more than most places, a lot more than anybody should. And Indonesia has a lot of those, more than anybody should have. They're going to cause some minor structural damage if you don't build your buildings right. About 100 earthquakes a year do serious structural damage, and about 15 earthquakes a year do massive amounts of damage. Usually Indonesia, Japan, California, the big earthquake zones. Every 5 to 10 years you'll get a big earthquake, like an 8 or a 9 on the Richter scale. And I say Richter scale, I'm about to tell y'all, it's the Mercalli, it's not the Richter scale, it's not the Mercalli scale, it's the magnitude momentum scale. But everybody just uses the term Richter scale because it's what everybody understands. So almost no chance to predict earthquakes. It just doesn't happen. Research is being done to predict short-term events that will tell you, okay, so next Thursday we should expect an earthquake at this latitude longitude. Research is being done, but the science is not there. It's not good science. Surveys are done. Trends are spotted. And scientists can tell you, scientifically, people can tell you, yeah, California's going to have 12 earthquakes today. They might feel 2 of them. Or they might not feel any of them. That's the scientific version. We can tell you the trend, the possibility. But if somebody says, I know there's going to be an earthquake, they're wrong or they're lying. There are no absolutes in science. There is, here's a trend and here's a possibility. That's science. That's good science. But if anybody says, I definitely know this is going to happen, that's a lie. That's politics. That's opinion. That's bias. It's not science. You cannot say this will happen. Kids, if I trip, I will fall. That's Newton's first law. But it's Newton's law of gravity. I apologize. Newton's law of gravity. But am I going to trip? I guarantee it. Absolutely 100% chance. But I'm lying. I might not trip. I might. I don't know. So long-term predictions are going to be trends, averages, what we've seen over time happen and what will probably happen in the future. And they're most likely going to be pretty accurate, but they're not going to say it's going to be Thursday at 3:45 and it's going to be a 5.0 on the magnitude momentum scale. It's not going to be like that. It's going to be, there should be about a dozen earthquakes. There's going to be 9 or 10 earthquakes in Oklahoma today. It's an average. It's going to be accurate enough to a point. So Pardon me. So earthquakes, not predictable. Tsunamis, not predictable. Volcanic eruptions, not predictable. We predicted one volcanic eruption ever. Evacuated the place, got everybody on the military base out of there. It was in the Philippines. The government said, this is costing us millions of dollars. If you're wrong, none of you will ever work, told all the geologists, none of you will ever work in this country, in the United States ever again. And the geologists were like, oops. But they were right. We predicted one volcanic eruption one time. And they said it'll be within these 12 days. And it was. But there is none of this, no, never. Mount St. Helens is going to erupt on next Wednesday. No, that is not science. That's a bunch of lies. If somebody turns out to be right, it's luck. That is not how it works. We don't predict these things. So, earthquakes, not predictable, but trends and patterns can be observed. And we can use those to extrapolate possibilities. And of course, in science, there is no absolute. If I say that the sun is yellow, there's no absolute, it's not absolutely true, because outside the atmosphere, the sun isn't as much yellow as it is inside the atmosphere. The atmosphere has an effect on the color of the sun. And so you go on to the space station, it's going to look more white than yellow. Something that science isn't true. No, science is close. It's not, there is no absolute. So there have been some serious earthquakes out there. There have been a lot of very serious earthquakes, and I wanted to talk about a few of them. In recorded history, now in the United States, there's very little recorded history of earthquakes before the 1800s, but in other countries, they've been writing these things down. So Shinsai, China in 1556, an 8 on the Richter scale. But how do we know? We didn't have seismographs. We didn't do it on the Richter scale. We did it on the Mercalli scale. The Chinese wrote down how much damage was done to buildings. And on the Mercalli scale, it says, well, if this much damage was done to buildings made of this material and this material and this material, it was an 8.0 on the on the Mercalli scale. And so it's not actually a Richter scale measurement. It's a Mercalli scale. It's an 8 on the Mercalli scale. But the Mercalli scale and the Richter scale are so close in similarities. The Richter scale is 0 to 10, Mercalli scale is 0 to 12. But an 8 on the Mercalli scale is probably a 7.5 on the Richter scale. And so it's pretty good data to tell you what exactly went on. An 8 will tear down wooden structures, brick structures completely obliterated. Concrete structures have a chance to stay standing, but there will be cracks in some of the concrete. An 8 on the Richter scale, or any scale you choose, doesn't matter really at this point. An 8 that's a tough day for everybody. 1811, 1812 in New Madrid, Missouri, big earthquake, 7.8 to 8.3 on the Richter scale, depends on who you ask. And the North American plate just moved and rifted all of a sudden. It just changed position. Major damage to small settlements pretty much everywhere along the frontier at that point. It was felt in Boston, which was 1,000 miles away. And so that was a pretty good one. That was a pretty big one. Very few 8.0s since then in that area. San Francisco, California, 1906, very famous, because San Francisco in 1906 was already a pretty big settlement. It's a pretty big city, and it just got all torn apart. And then because of course, 1906, some people are still using oil lamps, fires everywhere, all over the place. I mean, the buildings falling down and then lighting on fire because the oil lanterns inside of them just lit everything on fire, and it was just a massive disaster. 430-kilometer long fault line moved. 430-foot-long crack in the earth moved in an 8.1 in 1906 in San Francisco. Excuse me, man. The mold is high today and I'm coughing like crazy. Pardon me. All right, Chile, 1960 has the record for the big one, a 9.3 on a magnitude momentum scale. 2,000 people killed, 2 million people homeless. just it's tsunami later on. I mean, like most places in Indonesia, Philippines, Japan, they know if there's an earthquake and the earthquake stops, run for high ground. There will be a tsunami within minutes of that earthquake. The ocean will move because the earth moved. If the earth goes this way, the ocean goes that way, or the ocean sits still and the earth goes under it, it doesn't matter. Every time that these cities, these countries feel an earthquake, they know. Go to the high ground. In Chile, it's on a mountainous coastline, South America, western coast, very mountainous, tsunami, $75 million in damage. The earthquake was in Chile, and the $75 million in damage was Chile and Hawaii. They got the tsunami. The entire Pacific felt that tsunami and felt the earthquake. Just ridiculous amounts of $50 million worth of damage from the tsunami in Japan. I mean, this was a 9.3 on the Earth changed shape that day. The Earth's orbit changed that day. That's a 9.3 on the Richter scale, on the Mercalli scale, on the magnitude momentum scale. 9.3 changes the Earth and its orbit. The 9.1 in Japan in 2011 changed the shape of the Earth, changed the Earth's orbit. We're 1 foot closer to Japan than we were in 2010. And so the Earth's shape changed. We got closer to Japan, the United States. The Pacific shrank. Because the Pacific shrank, that water had to go somewhere, so it went up 33 feet and just dumped onto Japan. And then when the wave got to Hawaii, it was 6 feet tall. When the wave got to California, it was still 3 feet tall. The water just had to be dumped somewhere. It was just ridiculously powerful, amazing events that literally shifted the orbit of the Earth. Chile, 1960, and Japan, 2011, changed the orbit of the Earth. That's how big these earthquakes were. 1964, Alaska, an 8.4. Luckily in Alaska at the time, 1964, not a whole lot of people, but a 4-minute earthquake. An earthquake lasts 30 seconds. That's standard. 20 seconds, 30 seconds, 40 seconds. 4 minutes of earthquake in Alaska, 1964. That's why that one was famous. A fissure opened up offshore and drained some small harbors of water temporarily. I mean, it's pretty ridiculous what nature can do when it really gets mad. 7.3 in Haisheng, China, successfully predicted. The volcano started steaming. Sulfur smell, carbon dioxide, carbon monoxide, stinky gases all over the place, and then an earthquake. So they predicted, successfully predicted, 1975, 7.3 on the Richter scale in Haisheng, China. They actually figured out, hey, wait a minute, that mountain changed shape. Something's wrong. And then there was an earthquake, 7.3 on the Richter scale. So, I'm not going to get through all these. Tangshan, China, 1976, 7.8. Mexico City, 1985. Mexico City has some really strict building codes because Mexico City is built on soft sand because it's on a lake on top of a volcano. Dead volcano, extinct volcano. You would think they'd be okay, but if you give the guy $50, he'll ignore the building code and let you put your building up anyway. So Mexico City, horrible disasters when there's an earthquake in Mexico City. 25,000 dead, 1985, because nobody paid attention to the building codes. They have great building codes. They know they need them. The law says, don't do this, make sure you do this. But you bribe the guy and it doesn't matter because the building's just gonna fall down. 1994 to California and 6.7. 1989, California, 7.1. I'm going to have to do the rest of these in different presentations. So that'll be it for now. Lots of interesting stories backing some of these up. Some of them, rivers would flow backwards temporarily, accidentally. It's like, wait, hold on, wasn't the river going that way like a minute ago, and then the earth shakes and whoop, something's wrong. Anyway, earthquakes, fascinating, amazing stuff, kids. I could talk for hours, but I am down to 15 seconds, so I'll just stop it right